Today I will talk about discrete event simulation. It is part of my series of lectures on simulation and it is part of business analytics. This is my lecture outline. First I will give introduction, then I'll talk about discrete event simulation process, then I'll talk about uses of discrete event simulation, and then I'll talk about Python codes with an example of DES. So discrete event simulation is a simulation model where discrete sequence of events are modeled in time. Each event occurs in a particular time and makes changes in the state of system. Simulation time can directly jump to the occurrence time of the next event. This is known as next event time progression or time skipping. The simulation typically keeps track of the system statistics which quantify the aspect of interest. I'm sorry, this is tracking. Discrete event simulation is used to simulate system where events occur at a specified instances of time. Discrete event simulation does not track system stats continuously, hence it is also known as event-driven. Now, discrete event simulation process. The components of discrete event simulation include event list, statistical counter, system statistics, report generator, initialization routine, timing routine, event routine, library routine, and main program. So this is the discrete event simulation process. First of all, there is our initializing routine. It initializes clock, statistics, counter, and event list. So first of all, timing routine is invoked and we determine the next event. Then event routine is invoked and we update system statistics and we update statistics counter. Then we generate future event and we add to event list. And then the next event time is determined by timing routine and this cycle is repeated and then we finally collect the statistics. Uses of discrete event simulation. The common uses include model of queuing system, diagnosing process issues, for example, identification of bottlenecks in the system, find blocked or starved location, capacity or source in the process. We can improve design. An example is in operation theater sharing model of a hospital by various surgical departments. We can use DES in capital investment decisions, in financial modeling, in computer network simulation, in inventory management, and to identify failure mode. Then an example of Python code for discrete event simulation. So I will use SymPy package. SymPy package is discrete event simulation library. The behavior of active components like vehicles, customers, or messages is modeled with process. All processes live in an environment. They interact with the environment and with each other via events. Processes are described by simple Python generators. We can call the process function or process method depending on whether it is a normal function or method of a class. During the lifetime of the process, they create events and yield them in order to wait for them to occur. When a process yields an event, the process gets suspended. SymPy resumes the process when the event occurs. We say that the event is processed. Multiple processes can wait for the same event. SymPy resumes them in the same order in which they yield that event. An important event time is the timeout process. Timeout event occur after a certain amount of time has passed. They allow a process to sleep for a given time. A timeout and all other events can be created by calling the appropriate method of the environment that the process lives in, and that is environment.timeout. So in my example, the scenario is I have taken this example from internet. There is a movie theater and it has one ticket counter selling tickets for 3 movies of next show. When a movie is sold out, all people waiting to buy tickets for that movie, they leave the queue. A moviegoer tries to buy a number of tickets for a certain movie in a theater. So there is one theater, there are three movies, and a certain number of tickets are bought by a moviegoer. If the movie becomes sold out, the moviegoer leaves the theater. If the moviegoer gets to the counter, he or she tries to buy a number of tickets. If not enough tickets are left, he or she argues with the teller and leaves. If at most one ticket is left after moviegoer bought her tickets, the sold out event for this movie is triggered, causing all remaining moviegoers to leave. So this is the scenario. Now let us see the Python code. So first of all, we import certain useful libraries, including a random package, then SymPy package, and there is a random seed, and we have assigned 40 to it, and the tickets are 50 per movie, and sellout threshold is 2. So fewer tickets than this is a sellout, and simulation time is 120. So by this time, our simulation will run. This is the definition of a moviegoer, and the moviegoer lives in an environment, and the input variables include movie, number of tickets, and theater. So this is the code. So then this is the customer arrival. Now it is important that this is here we check whether there is a sellout situation, and this is the customer arrival process, and we have used here exponential distribution. So the number of tickets we have used random distribution. So this is the theater class, and this is the setup and start of simulation, and these are the three movies which are there, and this is a theater. Then we start the process until the simulation time, and we get this output as for this movie. So in 38 minutes the tickets are sold out, and number of people which leave the queue are 16, and for this movie the tickets are sold out in 43 minutes, and the number of people leaving the queue are 5, and for this movie we have a sold out situation in 28 minutes, and the number of people leaving the queue are 5. So this is all for today. Thank you very much.